how can we use the in assignment 6, how do we use the person class, right? You're not supposed to know, but in the same place, right, there is a person.java and an assignment6.java. So that gives you, that defines the person class, right? Since it's in the same package, you automatically get access to it. You don't have to import anything because you kind of automatically import your package. And I think, do the instructions tell you what kinds of things you can do or give you examples or stuff?
I think so, yeah.
Yep. But you can also look at person, and George will cover in this week or next how to define classes, right? But basically it has fields, first name, last name, and age, a constructor, and methods get first name, get last name, get age, and to string.
In the point object, p.x and y are integers, right?
Yes.
And then height and width are integers too?
Yes.
So if they are odd, how can we find the center of the rectangle? How can we find the center of the rectangle? Because when you divide it by two.
Yes. Choose the lowest one.
So yeah, I did it
Yes.
and I get
Sure.
100 and graded level you saw. I
Yes.
submitted it.
Yes. Choose the lowest one. Just do the standard division, right?
I try to multiply it with 1.0 and then divide it by 2 to get a double, but it didn't allow me.
Well, it would still work. You need, the thing is that what you're returning is also in. So you have to truncate it when you put it there.
So it wouldn't be a problem? So
No, just use the lowest one. It's kind of a problem in my spec, but the other classes are slightly uglier. There is a 0.2D with doubles and things like that, but we are using the super simple ones.
But get x and get y give you double, right?
Get X and get Y give you double because the super class is defined for doubles. But X and Y are ints. Or the interface. Let me check one thing. Okay. So we have talked about objects, right? Let me briefly go over that stuff. What's an object, right? Objects have an identity. They are different things, right? They have a state or a value, if you wish, and they have behavior, right? The methods that you can call on them. We have seen let's use points again as an example. How do we create an object variable? A variable that is going to reference objects. The same way that we create any other variable, right? We put the type and then the name of the variable, right? So point P. This creates a variable of type point. How do we create an instance of a class? How do we actually create an object, right? With the new thing, right? The new operator. Yes, I hope I did. Yes, I did. Does this make sense? And new actually by itself, right? It creates a point. It allocates a point in memory and returns it, right? Evaluates, yields that value. And then if you don't do anything with it, well, you just dropped it on the floor, right? Eventually, what happens to the objects that nobody wants? They get recycled, right? The memory is returned to the operating system. When? You have no clue. Eventually. Does that make sense?
No.
Hey. Objects can have fields that represent their state, and they also can have methods, right? Does that make sense? Now let me do it with strings. String s equals abc123. Oh, and we mentioned that objects have identities, so let's do it again. S equals abc123. Does a string have an identity? Yes, right? What happens if I do s equals abc123? What should I get?
S value will be always going to, it's like
Are they the same value or not? Are they identical or not?
yes, we should use dot equals.
We should use dot equals, and we know that dot equals would return true, right? What would equal return? The answer is magic. Well, Java does magic by default, right? When it is compiling, it doesn't create new strings, right? Because it has the constant value. The compiler has the value, so it doesn't create a new string. Kind of keeps a table of all the strings that it has created, and so it would return the same one, which would not be the same if we do new, right? This actually creates a new string, right? And so when I do s equals abc123, I will get false. Strings are special for Java. So Java does magic so that many times you get the right thing with equal. Does that make sense?
So is it working with Boolean now?
What do you mean it's working with Boolean?
Equals?
Equal always returns a Boolean, right?
If you use new, it should be like a point. It's pointing in another.
Yes. Yes. New allocates a new object in memory, like new in C++. Except that here I never use pointers. My variables are always references. In C++, the memory model is more complicated. In Java, primitives can live on the stack. Everything else lives on the heap. Heap. Basically, we have two kinds of allocating memory. Stacks are really, really cool, right? They only grow one way, and we normally represent them as growing up. Don't ask me why. So whenever you call a function, right, it's going to need space for all the local variables of that function, right? So it allocates that space on the stack. It knows that it's going to need 10 bytes. So it just increments the stack pointer. So now it has those 10 bytes, replaces, does whatever, right? When you're done with the function and you do return, you know that you don't need those 10 bytes anymore. So you just subtract 10, right? There's no holes, right? It just grows as you call functions and decreases as you don't call them, right? Or as you return from the function. And so it has very little cost. Stacks are beautiful. Call stacks are beautiful, right? It doesn't work when you start allocating objects in memory, right? Because since you did new, now that thing has to live in a different place. Because even after you are gone from the function, that memory has to stay allocated because you may return the object, right? And so Java and most other languages allocates those objects on what is called the heap. Tells the operating system, hey, give me some memory, right? and the operating system keeps track of that stuff. When that memory gets deallocated, what happens? You start getting holes, right? An object will be allocated, then another one is allocated, a third one is allocated, the second one is deallocated, so now your memory allocation has holes, which makes it a lot more complicated. So allocating and deallocating on the heap is a lot more complicated. Calling new has a cost. It's just computers are fast, so for the most part, who cares? With strings, they did the same kind of stuff. They did an optimization to make it usually faster, but you need to be careful because when you end up reading a string from the user or something like that, right, then that's not going to be, right? Equal is not going to work if you read a string from the user instead of use this as a constant. Does that idea make sense? What other objects can I call on strings? We learned that we can do length, right? I can do substring.
Replace.
I can do replace. What did that do? A with B. Does it do it by character or by string? Okay, it does it by string, right? And then what does this return? S.replace, right? Returns a string, right? So I can keep changing my things, right? And I can do stuff like this stuff ends up being costly, right? Because this allocated an object here, allocated another object here, right? So I end up calling new a bunch of times. Java is optimized, it tends to do it fairly fast, computers are fast, but you still need to understand that there is a cost, right? If you can put stuff on the stack and live with that, then that's a lot better. Does that idea make sense? Do you understand the distinction between the stack and the heap? And you will probably understand it a lot better when you go to data structures or when you go to computer architecture, where they talk actually. Yeah, data structures, you'll do them in C++, where the memory model is more complicated and you can see the distinction clearer. Data structures, computer architecture, you actually see the stack and the heap at that time. In Java, the main difference is that objects have identity, whereas primitives don't. The number tree is always the number tree, right? By the way, there are boxed classes. Int a equals 3. Int is always an int, right? But I can also do integer which is an object that just contains one int. So I can do all of these boxes are immutable. You cannot change them. You can only initialize them and then use them. But now this is an object, right? Does that make sense? We will talk about them later because we need to use them for one thing. And strings are objects, but slightly weird. Any questions about this stuff?
What is the integer?
Integer is a class, like point, right?
It's an object.
Sorry?
Is it an object?
Integer is a class. B is an object, right? B is a variable that references an object, right? Actually, classes are also objects. We are not going to do this, but you can do get class, and that tells you the class, and then you can call other stuff. For fancy stuff, you can use these things. Or it's called reflection. You can ask, well, this is a class, and class, tell me which fields you have, that kind of stuff for doing stuff that's in between compiling and normal programming. Definitely not in this class, but a class is also an object. Any questions about objects? Using objects, using points, rectangles, all of that stuff. Assignment 6. Assignment 6 should be incredibly easy, right? Cool. So, since there are no more questions, let me get a little bit ahead and start and we'll use, today is March 9th, right? Today is the 9th or the 8th? Women's Day. Oh, and we are working. Happy Women's Day, yeah. Today is the 8th. I am going to cheat because that's going to let us play more with objects. I'm going to cheat by starting to talk about classes. And hopefully defining classes also makes you, or actually let's do, rather than person, so you'll use person. Let's use my point so that you guys don't get confused with the actual point, right? We can define fields inside, right? And that enables us to do my point p equals new my point. Things like this. What happens if we try p equals p2? What's the answer to this? What would this print?
Well,
Okay, it would print true or false, and that's an advantage, right? Which one?
False.
False. Why?
But they are not the same, they are not.
They're not the same object, right? They're two different objects, right? I created new, right? So like two different objects that happen to have the same values, right? Actually, given that everything inherits from object, I always have a equals, and I always have a toString method. But their default implementations are not necessarily any use. The default implementation of equals just calls equal equal. And the default implementation of toString prints the name of the class and a horrible number in hex.
You add something else like in X, Y, and Z. Can you use P dot Z, for example?
Yes, if I add one more variable here, right?
You
Then
can add whatever you want.
both of them, yes, yes. Yes.
Since it's a static class, do you still need to create an object for this? Can you directly use E to?
Well, okay, that is a static class just means that you still need to create objects, but if not, you still need to create instances if you need an instance. The class being static just means that it doesn't really keep a reference to its parent class. So it's basically because I'm cheating. I should define this in two files, but I'm too lazy. So by defining it static, it's just an inner class. You normally don't do this. You normally start creating more files. But I find it in teaching, it's a lot easier to have it all in one file rather than have a bunch of files together. Yeah, we could do those kinds of things, right?
oh, you said that point is only two integers, right? X and Y.
This is a 3D point that has 3 ends. C as for Z. Now, it's our class, right? We can do whatever we want. The AWT point has only 2 integers, right? But this is our thing, right? Let me. What happens if I do private? All of these things become compiler errors. Oh. Ooh. Never mind. Given that I'm inside this class, even though they're private, they're still accessible by these guys. Which is horrible. Private doesn't mean private. I can also define methods. When I define a method, inside the method, I can use this to reference the object that the method is being called on, Does that make sense? When somebody calls the method, somebody's going to do something that produces an object, dot, and then the method, right? To refer to that object, I can use the keyword this. And I don't actually have to. So in this case, right, when I write x, which x? It's the instances x. Does that make sense? So if somebody was here to do and if we do what do we expect to get printed? 3 and 13, right? Does that idea make sense? That's related to this identity of objects. Isn't that cool? Any questions on this? No? You have all tried assignment 6 and it's super easy? Yeah, it's mostly easy, right? Cool, then let me keep going with classes and maybe we'll get ahead. Sorry?
But not everybody might have tried. I guess it's easy, but
But you haven't compiled it and run it. We normally do this stuff, right? It is tradition in Java to have getters, right? Get and the name of the variable. You capitalize the first letter of the variable. In this case, it's only one letter. And then to have setters, set. Okay, here we get into trouble, right? What happens if we call this parameter with the same name as the field, which would be a good name, right? Well, what does this x reference to, right? Or actually, we want to do x equals x, right? But in this case, we want the variable, the instance variable x, and in this case, we want the parameter, right? So how can we distinguish? One way is to do this dot x here, because we know that the parameter will win. The other one is to call our parameter something else. And then that's perfectly okay. You don't have the same names. Does this idea make sense?
Or can we make the other one integer?
Here, you can, but that declares a new variable x inside this function that's local to the function. You didn't change this guy. Right? I recommend that for now, you write it like this. Oh, this should be void. You actually write this the first couple of times to make sure that you understand what is happening when you just say x. Right? But Now we go with magic. Constructors, right? A constructor is like a method, but it's gonna be called when the client calls new, right? They can still be public or private. It has the same name as the class. This is kind of the empty constructor, doesn't do a thing. And then we could also define constructors. So now I can do things like this. Make my code prettier. Go here. I'm calling it by this, right? When I call new, now I'm calling the constructor that takes two parameters because I'm passing two parameters, right? So it's constructor overloading. Make sense?
It has to be the same name as the class.
Has to be the same name as the class, which was a cool hack in the beginning, right? But it's actually slightly painful sometimes when you need to change the name of the class. But has to be the same name as the class, and the other weird thing is, what does it return? Well, it's not quite a method. It doesn't actually return nothing. It's not the same as void, right? You just don't have a return type. You're not returning. Whoever called you is still going to return an object, right? So the operator new instantiates the memory for the object, calls the constructor, and then still returns the object, not whatever the constructor did. Does that idea make sense? And the constructor allows you to decide what's available. If you do this and don't define a constructor that takes no arguments, you now cannot do this. Now it's going to tell you you cannot just create one with no arguments. Does that idea make sense? Isn't this cool? Trying to not do your assignment for you. Trying to remember not to do your assignment for you. What's this?
You've already done the how.
Sorry?
You've already done the how.
No, you don't. That's a further assignment, not this one. This is for the next one, maybe. think rather than keep going ahead, we should stop here and give you guys back 3/4 of your life. 3/4 of an hour of your life, not 3/4 of your life. That would be really cool. That would be really cool.
Magic computer science.
Yes. We are not that good. Not yet. Unless you guys have any questions or want to cover anything. This is enough to prime your brain. We'll cover classes next week. No questions. Life is good. Cool. Let me stop this.